Today we are going to see NPV, IRR and the project selection based on NPV. The first part is NPV. I deliberately started with a blank screen so that you learn how to make it from scratch, and I will be doing it. So you can see here I am making this box. The box I'm saying cash flow. The next box I'm saying PV factor. So I will make you understand what is PV factor, and this box is years. So let's put it like this, years. So suppose it's a 10-year project. So it's a 10-year project or 15-year project, long project. So let's keep till 15 years, remove the rest. Cash flow. So here we have to understand one thing. You have to put the cash flow here first, fundamental basic, that what kind of money is going to come back to us. So anything which is coming back to us is positive. So let's do that. So if we observe, we can see that the cash flow is not in an order. So first of all, it's starting with 10,000, then 9,000, 9,900, then it is coming down to 6,300. This particular phase, 6 years, 7 years, and 8 years, it is pretty high, 12,000 to 15,000 range, 16,000 range. From 9th year to 11th year and 12th year is pretty low. Again, 13th year, 14th year, 15th year is little on the higher side. So that means there is no direction, there is no pattern in such a cash flow. So PV factor comes to help in these kind of situations. So the fundamental of PV factor calculation you will get a lot in YouTube videos, but nobody talks about the fundamental. Fundamental fact is the future forecasted inflation rate. That is the PV factor concept, in the sense you should grow as much as the inflation grows. So if inflation is growing at 8%, ideally you should also grow at 8%. So the average inflation for 15 years, if it is 10%, then you should ideally grow at 10%. Then your PV factor is 1 divided by 1.1. For the first year, it is, I'll just write here, then you'll understand. So let's write here in this box 10%, and then here let me write it for the first year. So the first year it is 1 divided by, within bracket, 1 plus. Now this particular cell we have to take C2. So we will fix the cell. So how to fix? $C $2. So the cell is fixed. To the power 1. That's for the first year. So to the power 1. So that is a PV factor. If we draw it, we'll get for all the years. So the PV factor. So cash flow multiplied by PV factor is going to give us the present value. And let's calculate the present value. So it's nothing but this multiplied by this. So this is the present value for 1 year. So you basically can understand that in a simple concept that 13,000 rupees are coming to me, but it is coming after 15 years. So the value of 13,000 reduces to 3,112. If you ask me the question that, sir, will I get a check of 13,000 or will I get a check of 3,112? My answer will be you'll receive a check of 13,000 itself. But the value of that money will be reduced to 3,112 15 years down the line. So 15 years down the line, the value of 13,000 reduces to 3,112 rupees, provided 10% remains the average inflation over the 15-year period. That is the concept. Now we will add these entire present values up. So we will just sum it up, the entire present value from here till here. So when we add it up, we will get something of this kind. So it's 67,780 rupees, approximately, some paisa. So this is the value. Now, how to take a decision how to take the calculate the NPV and the decision. So we have to minus the project cost. Suppose the project cost is 17,500 rupees. That's the project cost. So after the project cost, how much is going to stay with us? That is basically the profit. So after the project cost, 50,000 is staying with us. So that is the net present value. So this is the project cost. So after the cost, we still have net present value of 50,000. So the simple decision is we can recommend such a project. We only on financials we cannot accept a project. We have to see a lot of other things, a lot of operational constraints. However, on purely financial perspective, we can say that since the net present value is something quite substantial, so we can definitely recommend such a project. In continuation of our work, now we have seen three projects are there: project A, project B, and project C. If we watch carefully, then we see that project B has more money coming up between first year to sixth year. On the contrary, project C has more money coming from fourth year to 15th year. In fact, from 10th to 15th, a lot of money is coming out. But interestingly, project C, first 3 years, there is no payout. So let's calculate the PV factor. So PV factor calculation will be same because we are comparing projects. So 10% is the average inflation which is going to be in another 15 years future. That's a strong assumption, but we have to rake it, and we have to freeze cell number C2. So dollar C dollar 2, that is fixed, and then to the power 1. So these ones we have to delete, not required. These ones, and also this one. So now we can copy this from here because you know the calculation. Again and again, no point doing the same calculation. So I must paste as numbers, and then I must calculate the present value for all these. So now let's calculate and then do a summation. So just to do a simple summation here, each year how much it is getting, what is the total money which is coming to us in essence. Suppose to compare better, let's keep the project cost same. So project cost, let's keep it same so that we can calculate better and we can compare better, and our decision making capability becomes better. But in real life it may not be same. Be prepared for that. However, for calculation's sake, I'm just showing you. So we are seeing some very interesting outcome. I'll complete the calculation first, and probably then I'll show you the decision part. Sorry. So project cost I'm keeping the same. Minus 17,500 and how much is the money that we are getting. So interesting, though project C gets most of the money after third year, and in fact it is bottom heavy. Bottom heavy means from 10th to 15th year most of the money is coming back, yet the net present value is 58,905, where the other ones are slightly weaker. Project B receives most of the money in the front loaded project. We call it front loaded project, where most of the money is coming in the first few years. However, since the total inflow of money is less, that's why the impact is certainly less. So, between these three projects, my choice is project C. Despite the project C has got certain limitations, you can see it clearly, but still, on a comparative basis, when the PV factor is the same and the project cost is the same, ideally, project C should be chosen over the other two projects because of sheer NPV, net present value. Thank you.